Alright, welcome back to Scholar's Shack doing some math. Today we're working in chapter 6.2, properties of rational exponents. We would have seen this last chapter as well, but we're going to be working with higher exponents. So let's review over the exponential rules we have. So if we have two numbers of the same base with different exponents, and then we multiply together, we just add the exponents together. am plus n. So for example, x to the third times x to the fifth, example 1, that'll be x to the 3 plus 5, which is 8. Example 2, we have x to the 1/3 times x to the 1/2, which is the same thing as x to the 1/3 plus 1/2. And if we remember how to add fractions, that'll be x to the 5/6. Example 3, 5 to the 2 plus 7 is 9. Example 4, 5 to the 3/4 times 5 to the 1/4, that's 5 to the 4/4, which is the same thing as 5 to the first, which is 5. Okay, let's look at this other rule. If we have a to the m to the n, then we multiply the exponents. So mn, so 2 to the 4th is 2 times 4, which is x to the 8. Oh, geez. This is x to the 24/36. And that reduces to 2/3, or x to the 2/3. This is 5 to the 6th. This is 8 to the 15/2. Okay, next one. We have two numbers being multiplied together, like, let's say x and y, well, we have a and b here, to the mth. That means we distribute our exponent to both of them. So this is a to the m, or b to the m. So this is x squared, y squared. And this is x to the 3/2, y to the 3/2. This is 3 squared times 4 squared. I mean, you could have done the parentheses inside first and did 12 squared, because this is just squaring, which is not so bad. And obviously this is 9 plus 16, which is 20. Wait, what? Wait a minute. Pause. Okay, I know what I did wrong. It's 9 times 16, which is 144. Okay, and then 4 to the 1/2 times 9 to the 1/2. Now the other day, we remember that the 1/2 power is equal to the square root. So the square root of 4 times the square root of 9, that's 2 times 3, which is equal to 6. Okay. A to the negative m. So when we have a negative exponent, all we do is flip it over our fraction, or move it to the other side of the fraction bar. So my students are getting confused when I say flip it, so I'm going to say you move it to the other side and then make the exponent positive. So this is 1 over x to the 3rd. This is 1 over x to the 2/3. This is 1 over 4 squared, which is 1 over 16. And then this is 1 over 36 to the 3/2. And then from yesterday, we should know this as 1 over under the second root, or square root of 36 to the third power, which is equal to 1 over. So the square root of 36 is 6. 6 cubed is 216. Alright, if we have an exponent to the bottom, we just move it to the top and make it positive. So this is equal to a to the positive m. So this is x squared. This is x to the 1/3. This is 3 squared, which is 9. And this is the square root of 36. So 6. So what you missed here was I moved it up. And it's 36 to the positive 1/2. That's the same thing as square root. Okay. This one. Oh, this is a negative exponent? Okay. So remember, this is a to the negative m, b to the negative m. That's me distributing my exponent. And then that'll change to b to the positive m up top. Because remember what we do with negative exponents. And then the a moves to the bottom. So this is y squared over x squared. This is y to the 1/4. X to the 1/4. This is 3 squared over 5 squared, which is 9 over 25. This is the square root of 3 over the square root of 5. We don't like having square root of 5 in the denominator. So remember, before I do that, this is just 3 to the 1/2, 5 to the 1/2. Whenever you see 1/2, that's square root. Okay? So I'm going to multiply top and bottom by square root of 5. And I will get square root of 15 over 5. Okay. Now when we're dividing from the same base, so all the way back up here to the top, we were multiplying of the same base, now we're dividing by the same base. We just do a to the m minus n. So this is x to the 5 minus 3, which is x squared. This is 3/4 minus 1/3. So this becomes x to the 5 12. This is 2 to the 5th minus 2 to the 5th divided by 2 to the 1st. So here's a perfect example of what's going on here. I have 2 to the 5th, which means 2 times 2 times 2 times 2 times 2. And then I have 2 at the bottom. Cancel 1. So I'm left with 3 to the 4. Which is 2 squared is 4. 2 cubed is 8. Times 2 is 16. This one is 2 to the 3/2 minus, or this is 2 to the 3/2 divided by 2 to the 1/2. So that is 2 to the 3/2 minus 1/2, which is 2 to the 1, which is 2. And then the last property we have, no, we have more. Okay, here we go. This is just a to the m, b to the m. I don't know why this wasn't done earlier. X to the 4th, y to the 4th, x to the 3/2, y to the 3/2. You get the drift. Let's move on next. Okay. New stuff-ish. So if we have something to the nth root, that means we can take the nth root of that times the nth root of that. So that's the nth root of x times, well, actually, we know that one. Oh. Okay, so in example 2, turning it up a notch. So this is the square root of x cubed y squared. So what I'm going to change this into is the square root of x squared times the square root of y squared. And then you're asking, what happened to the other x? It's right here. What's the square root of x squared? X. What's the square root of y squared? Y. What's left? The square root of x. Okay, gotta be careful, because now we're dealing with cube root. This is the cubed root of 27 times the cubed root of 8. And that's 3 times 2, which is 6. Next. The fourth root of x to the fourth and y to the eighth. So that is that is the same thing as the fourth root as x to the fourth times the fourth root of y to the fourth times the fourth root of y to the fourth. So I get x times y times another y, which is xy squared. Okay. Next. The nth root of, okay, that's the same thing. That's a, we've seen this before. Oops. That is the nth root of a divided by the nth root of b. So this is the square root of x over the square root of y. This is the cube root of x cubed, and the cube root of y to the third, if that's a y, there we go, and another cubed root of y to the third, which means this would just be x over y squared. 4 over 9, square root of 4 is 2 over 3, okay. Fourth root of 1 is 1. Fourth root of 64 is 4, no. Oh, 2 times 2 is, wait. I don't know. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's not it. 4 times 4 is 16, times 4 is 64. Okay, that means I have to split 64 into the fourth root. So right now I'm breaking 64 down into numbers that'll give me a perfect quartic. So a perfect quartic would be 2 to the fourth, which is 16. And that is 4 right there. So this is the 16 times the fourth root of 4. Please. Whatever. So up top we have 1. And then the fourth root of 16, which means 2 to the what power is, or what, sorry, what to the fourth power is 16, that's 2. And then we have fourth root of 4 in the bottom. And we're going to skip this part because we have a square root, or we have a radical denominator. We don't like those. And that's what we do down here, this next part. Alright. So when we're trying to rationalize the denominator, when we did it before with square roots, we just multiplied it by whatever it is. Now we need to multiply it by just enough. Okay? So we have the fourth root of 3 in the denominator. What can I multiply this by? So it's going to be fourth root. And we're going to do it to the top or the bottom. What can I multiply 3 by to be a perfect quartic? So I'm going to look at my list here. 2 to the fourth is 8. 3 to the fourth is 3 to the fourth is 81. Okay. So it's already getting pretty big. And then actually 2 to the fourth is 16, sorry. Okay. So can I multiply 3 by anything to get 81? Yes. I'm going to do it. 3 times 27 is 81. all I did was I looked at my list. I'm like, maybe 3 goes in 81. It does 27 times. Okay. What I do to the top or bottom, I must do to the top. So I have 5 times the 4th root 27 up here. And then when I combine these, I will get the 4th root of 81. Which means this will become 5 times the 4th root of 27. And then on the bottom, we'll just get 3. Okay. Feels like I break my glass. Just pen stroke sometimes. Anyways, well, that's just a pen stroke. Boop. Alright, the next one would be taking, so just timesing top and bottom by cubed root of something. So let's look at my cube list. 2 to the 3rd is 8. And I can stop right there because we know that 4 times 2 is 8. What I do to the bottom must do to the top. So I will get the cubed root of 12 up here and the cubed root of 8 down here, which becomes just 2. And can the 12 be broken down into perfect cubes? Let's look at our list. No, I could not. So we're left with the cube root of 12 up top. Alright, let's look at these 2 rules. Just remember, when the index is odd, this end number 13579, we just keep x the same. When n is even, always positive. Okay? When you're taking the nth root of something to the nth power, which means they're canceling, right? Okay? So, for example, if we have this, we just have 5. But if we have negative 5, it stays negative 5. So we're keeping the sign. But if we have this, we can keep 3. And the negative goes away. Okay? Because you would do negative 3 to the 4th power first. And that's a positive number. And then when you take the 4th root of that number, you get 3. Now what happened to that plus or minus stuff? Remember, we only do plus or minus when solving, algebra. When there's an equal sign involved. I mean, what I always tell my class is, if you have to write the square root, if you have to write that, because you normally have this situation where let's say you have x squared equals 9. When you have to you yourself have to put down the square root, then you get x equals plus or minus 3. But if your problem was given like this, it's just 3. Okay, that's enough of that lesson, right? Right? Oh no. Wow. Okay. 4. Here we go. This is just a bunch of examples, so this is a lot. Why is this just... why? Okay. Just like a homework assignment. Here we go. So, first thing I'm going to do is going to apply that negative 1/5 here to both these. So this is 4 to the 5th times negative 1/5. 3 to the 5th times negative 1/5. Okay. And that becomes 4 to the negative 1 times 3 to the negative 1. Okay. So let's put our fraction bar. Let's make it exist now. Those are going to move below. So I have 4 times 3, which is 1 over 12. Okay. Number 2. Oh, jeez. Okay. So this will be 20 to the 3 halves. Okay, remember I'm just multiplying it to both of these here. 5 to the 3 halves. And just remember, like before, we can reduce this because they're of the same power. So this is 4 to the 3 halves. And remember, from our last section, 4 to 3 halves, we put this is the power, this is the root, so this is the square root, so that's where that 2 comes from, of 4, and then we're going to cube it. So square root of 4 is 2, 2 cubed is 8. Okay, next. Crazy stuff. Okay. So, well, we have fractions. So this is x to the 3/4. So up top, I'm going to have x to the 3/4 minus 1/6. Okay. And then on the bottom, we have y to the 3 halves plus a negative 1/6. Okay. Lowest common denominator for the top is 12. So I'm going to multiply this by 3 and this by 2. So I get 6 twelfths plus, or this is 3. 9 twelfths. 9 twelfths minus 2 twelfths. And we're going to get x to the 7 twelfths up here. And then on the bottom, going to skip ahead to y over 8/6, which becomes x. We'll keep the same top, and then on the bottom, we'll have reduced that to y over 4/3. Oh, jeez. Okay, here we go. So, remember, this gets distributed to all these. Even the number. So 27 to the 3rd. P3 to the 3rd. So times Q 1/3 of 12. So 27 to the 3rd power is the cubed. This is the same as the cubed root of 27. 3 times 1/3 is p to the 1st. And then the 3rd of 12 is 4, so q to the 4th. So my final answer is 3pq to the 4th. Number 5. Okay. So first we're going to do this. Distribute that there and distribute this here. Again, what's up with these fractions? So this is going to be a to the 3 times 3, which is 9. And then this is going to be b to the 3 halves times a to the 2/3 times negative 1/4, which is negative 2 twelfths. That's an a there. And then b to the positive 3/4. Because it's positive. Because that's a negative 3, that's a negative 1/4 there. Okay. Put my a's together. So this is a to the 9 minus 212. And this is b to the 3/2 minus 3/4. So the common denominator is 12 for the first one. But I'm going to skip ahead. So that'll be 106 over 12. And then b is going to be 9 over... Wait. Yeah, 9 over 4. That's a plus sign. So reduce this. A to the 53 over 6. B to the 9 over 4. Okay. Alright. Number 6. Go look at the numbers. 14 divided by 2. 7. Nice. Okay. X to the first minus 3/4. And then y to the 1/3 up top. And z is going to move up top and become positive. So this is, well, so there's nothing left on the bottom. The 2 went away, that went away. Yep. So my answer is 7, x to the 1/4, y to the 1/3, z to the 6th. Oh, wasn't so bad. Okay, some review from yesterday. Fourth root of 27 times fourth root of 3. So remember, radicals, the numbers under the radicals, or the radicand, we can multiply them together. So this is the fourth root of 81. And what's the fourth root of 81? Let's check. 2 to the 4th is 16. 3 to the 4th is 81. So this is 3. Okay. Cube root of 135. Ew. So what I do is, looking for factors, I just use my perfect cubes. So 2 cubed is 8. So I take 135 divided by 8. That doesn't work. But 3 cubed, that does work. 27. 27 actually magically divides evenly in 135 by 5. So this is negative 2, that number in the front. Times the cube root of 27 times the cube root of 5. Da, 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 da. So this is negative 2 times the cube root of 27, which is 3. Negative 2 times 3 is 6. Negative 6. So we're left with negative 6 times the cube root of 5. Okay. So we have the two numbers being divided by cube root of 250 divided by the cube root of 2. That's the same thing as the cube root of 125. I just did 250 divided by 2. And the cube root of 125 is 5. Okay. Split this up. Cube root of 54. We like to use this number a lot. This is the same thing as the cube root of 27 times the cube root of 2 times the cube root of x cubed times the cube root of... So y to the 5th. Remember, that's just y times y times y times y times y. So I'm going to take 3 of these y's, because the cube root of y cubed is just y. So I'll put it here, if my pen will let me. And then we're going to multiply one more thing. Oh. And it's going to be what's left over, these two y's. So this is y cubed times y squared. So cube root of 27 is 3. And then 2 is going to be under the cube root. Oh wait, let me make some more space. Sorry. So here's the cube root, and then here's what's outside. So we have 3 outside. The 2 is going to stay inside. And then an x is going to come out, and a y is going to come out, and then we still have 2 more y's inside. So that's our answer. Next. Okay. Split it all up. This is the 4th root of 4 times the 4th root of a to the 4th times the 4th root of a to the 4th. I mean, one way to look at it. So we're doing 4th root, and we're doing b to the 14. You divide it, so 14 divided by 4. That's 3 with 2 remaining. Okay. But I'll show you all the steps. Times the 4th root of b to the 4th times the 4th root of b to the 4th times the 4th root of b to the 4th. So that's that's b to the 12. And then we have 2 more b's. Okay. So for the b's, 4th root of b. Wow, this is looking really terrible. B squared. There, that's what's left. And then we have c to the 4th. And then we have 1c left. Okay. So 4 is going to stay on side. A is not. There's actually 2 a's coming out, so that's a squared. And then there's 3 b's coming out, so that's b cubed. And then there's 1c coming out. And we're left with b squared, c inside. Okay. So 2 a's are coming out and being multiplied together. That's why I have a squared. We have 3 b's. And then, 1c. And then this number here is the 4th root. Okay, number 6. 4th root of 64. So I'm going to clean this up a little bit more simpler. So this is the 4th root of 16 times 4 times a to the 4th times a times b to the 4th times b third. Boom. 2 goes outside. That's the 4th root of 16. What's left inside is 4. We have an a to the 1st coming out, and then an a inside. 4th root of b to the 4th is b. And then we're left with b cubed inside. Okay. Well, what is this? What is this? Why are we doing this? Okay. So luckily, this number here is to the cubed. Because we could just take it right out right now. So we have x minus 5. And then on the inside, and this is parentheses by the way, on the cubed root of x cubed minus 27. That's what we got inside. And we can't do anything because that's a subtraction sign. It's not to the cubed power. We're done. Without knowing what x is. Okay. How many more? Wow. Wow. This will be a long video. Okay, here we go. Let's power through this. So rewrite your answer in simplified root form. So rewrite your whatever this is as an exponential fraction. So remember, that's my root, that's my denominator, denom, and then this is my power, which is my numerator. So x to the 2 over 6, which is x to the 1/3, done. This is the 2 to the 1/2 times 2 to the 3 or 1/3. So this is 2 to the Wait, where am I? Oh, yeah. Which is 2 to the 5/6. Oh, okay. I did not read correctly. Simplified root form. That means it has a root. That means this is the cubed root of x. And then this is going to be the 6th root of 2 to the 5th. Yep. Oh, come on. The 5th root of the square root of x. What are you guys doing to me? What are you doing to me? This is the same thing as okay. On the inside we have x to the 5th. And then on the outside we have the square root, which is 1/2. And then on this one we have x to the 1/2 inside, and then to the 1/3. So this is the x to the 1/10 times x to the 1/6. Okay, I'm not going to give you guys this many fractions, but you guys need to practice this. Lowest common denominator is 30. So this will be x to the 3 over 30, because I multiplied the top and bottom by 3 to get 30. This one I have to multiply the top and bottom by 5. So plus 5 over 30, which is equal to x. So yeah, was it 8 over 30? Which reduces down to, I don't know why I'm going upwards. This is crazy. 4 over 15. And then we'll just go backwards. Normally I go left, right, and go down and stuff like that, but for some reason I'm going backwards. So my answer is this crazy thing, the 15th root of x to the 4th power. Okay, so notice how I put this in parentheses and put the 5th power outside. You can put the 4th power inside the square root. It doesn't matter. Number 4. Man, these are like all the... This is like... Okay. This is a to the 5th, 5 over 4. B to the 5 over 4. That's just 1/4 times 5. And then down here, we have a to the 1/2, b 1/2. Okay. So this becomes a to the 5/4 minus 1/2. Same thing with the b's. So this is going to be, these 1/2 will become 3/4. So A to the 3/4, B to the 3/4. So this is the 4th root of AB to the 3rd. Yep. Okay. So let's break this up. This is x to the 4th y squared to the 20 divided by 5. See what I did there? So this is the denominator, remember? And that's denominator, and then that's the power, or the numerator. So that makes it a lot easier, because that's x to the 4th y squared to the 4th. My pen is not working well. Okay, I was able to reduce the fraction. That makes it a lot easier. Now this just becomes x to the 4 times 4, which is 16, and then y squared to the 4th is 2 times 4, which is 8. Done. Okay. Number 6. The 4th root of the 3rd root of 2x squared. So to translate this, we're starting off with 2x to the 2/3, and then afterwards we do it to the 4th. This is not so bad. It's multiplication. So this is 2x to the 2 over 12, which is 1/6. So that is 2x to the 6th root. Okay. 42 minutes. Let's go. 4th page. Should have took a break. But it's a lot easier to know. I'm just going to have in my class, I'm just going to have the chart filled out completely. And then we'll just do this page together. Because that's a lot of time. I have less than 15 minutes in my class. And to even go through all this, like, without even taking questions or... Oh, this is ridiculous. Okay. Rationalize the denominator. You rationalize the denominator. Here we go. Cubed roots of 3 over the cubed roots of 4. So what do I need to multiply the bottom by to get rid of it? Okay, by the least amount. So let's look at 4 first. 4, and we're looking at perfect cubes. So we have 2 to the 3rd power, which is 8. Okay, that's what we're going to do. So we're going to multiply our 4 by 2. Now how do we get rid of the y? Well, we're going to multiply it by y squared. Because y times y squared is y cubed, and the cube root of y is y. And that gets rid of our silly square root. I mean radical. Okay. So on top, I'm going to get 6y squared, cube root. And then on the bottom, I'll get 8y cubed, which is the same thing as 2y. Cool. And that's it, right? Yep. Next. 5th root of 8. Well, let's look at our 5th root. 2 to the 5th equals 2 to the 4th, 16. 2 to the 5th is 32. So I'm just going to multiply my bottom number and my top number, because it has to be the same, by 4. 8 times 4 is 32. So I'm going to get the 5th root of 28 up top. Nothing can you do about that. And then we got fifth root of 32 in the bottom, which is 2. Next, it's a little bit blurry, but this is the fourth root of 3x. This is the fourth root of 4y. Okay. What do I need to multiply top and bottom? Okay, fourth root. Look at 4. 2 to the fourth is 16. So I'm going to multiply this by 4. And then I need 3 more y's, because these are fourth roots. So 4y cubed. So this becomes the fourth root of 3x, or actually 12. 12x y cubed up top. And then on the bottom, we're going to get 2y. Okay. Combining like terms. Oh, yes. Somewhat easier. It's number 1 here. So what I like to think of it, this is 1/5 square roots of w plus 3/5 square roots of w. How many square roots of w do we have? We have 4/5 square roots of w. With my class, I like to say 1/5 apple plus 3/5 apple is 4/5 apple. But it's something you get used to. Just rearrange your words, like, you just cover it. 1/5 of blank plus 3/5 of blank is 4/5 of blank, right? So, for example, we have a bunch of this junk here. And I'm just going to call it smiley face, or smiley face, smiley face. 3 smiley faces minus 8 smiley faces is -5 smiley faces. Which smiley face equals xy to the 4th. Okay. Interesting. So this one takes some simplification. So the square root of 9w is the same thing as square root of 9 times the square root of w. So this is 3 times the square root of w. And then we have minus. So I'm looking at this part here. So we have w outside. And then this is the same thing as w squared times w. The square root of w squared is w. So I'm left with w squared about here. And then we have w inside. Okay? So now we have the same square root. Okay? So this is the same thing. If I have 3 square roots of w and w square roots of w, and I'm going to subtract them, that is the same thing as 3 minus w squared, in parentheses, square roots of w. Okay. Same thing with that whole apple thing. 3 apples minus w squared apples is 3 minus w squared apples. If that makes any sense. Next. Twelve cubed. Oh. Okay. So it takes some simplification. And how are you supposed to recognize this? It's just, I guess you can say if there's a minus and a plus sign. It's just because you're taking this chapter, so you're working on this section, you kind of just see there's a plus and minus sign and things that look alike. Alright, here we go. So this is the cube roots. So I'm going to pull I'm going to pull 3 v's out. So 12v, and then we have the cubed root of 2, what's left over, v squared inside. Okay? Minus v cubed. Cube root of 54. Let's break that down a little bit. That's the same thing as 27 and 2. And then v squared's left inside. Okay? So this is going to be 12v cubed root of 2v squared minus cube root of 27 is 3. And then we have v cubed 2v squared outside. Yeah. Just to be sure. Oh, sorry. No, I'm fine. So this is the same thing as... Oh, did I misread? I misread this. Okay. Oh, jeez. So this is not v cubed. This is v cube root. And that's something you guys definitely got to watch out for. I read this as v cubed to the cube root instead of just v to the cube root. So I have 12v minus 3v. So 12v apples minus 3v apples is 9v apples. Okay. Ah, is this an easy one? I think this is an easy one. Negative 5 apples plus 1 apple is negative 4 apples. See? Negative 5 apples. Negative 5 unhappy faces. Oh, sorry. Negative 5 unhappy faces plus 1 unhappy face is negative 4 unhappy faces. Okay, 6 apples plus 4 apples minus 2 something different. Okay, so this is what we do. We add like terms. We have 10 apples here. And then 2 oranges. Or minus 2 oranges. See? Well, it can only add like terms. Boop. Distribution. This is x to the 1/2 times x to the 2/3, x to the 1/2 times x to the 4. This, and that's the same thing as x to the 1/2 plus 2/3 plus x to the 1/2 plus 4/5. So this is x to the 7/6 plus x to the 13/10. Yeah. Two and 5 is 10. 2 and 3 is 6. Okay. Foil. Isn't this a little much? I mean, I'm killing them. I feel like I'm killing my students here. Killing myself. Here we go. Foil. So I'm going to take this times this times this times this, and this times this. That is foil. First, numbers. Outside numbers. Inside numbers. Last numbers. Okay. x to the negative 1/4. So we have x to the negative 1/4 times x to the 4th, which is the same thing as plus 1/4. Then we have plus x to the negative 1/4 plus 5/2. Okay? And then we have plus x to the negative 5/2 plus 1/4. And then we have plus x to the negative 5/2 plus 5/2. Okay. It's not so bad. First one cancels. X to the negative 1/4 plus 1/4 is 0. Right? Don't remember. Yep. This is x to the 0. This is this be x to the 9/4. And then plus x to the negative 9/4 plus 1. Wow. Oh, well, this is also x to the 0, by the way. So x, anything to the 0 power is 1. So I have x to the 9/4 plus 1 over x to the 9/4 plus this 1. So this is 1. This is 1. So that's 2. Okay. This is not so bad. This is another FOIL problem. So it's the same thing as y to the 3/4 minus 4 times y to the 3/4 minus 4. It's saddening. Okay. But this just becomes y to the 6/4 minus 4y 3 to the 3/4 minus 4y 3 to the 4th. Plus 16. And that reduces to y to the 3/2. And then these combine 8 to the y to the 3/4. And then we have the 16. Okay. Looking at this, and you don't have to use the box method, but I just wanted to show the box method. I just like doing this, rainbows. I like making rainbows. It just means I'm multiplying these 3 numbers and I'm adding them through multiplying these 3 numbers. Some of you guys like the box method. So for the last problem, I'll use the box method. So x to the 2/3, x to the 1/3, plus 2. And then on the left side here, we have x to the 1/3 minus 2. So when we multiply that all out, we're going to get x to the 3/3 here. We're going to get x to the 2/3. And then we're going to get 2x to the 1/3. Here we're going to get negative 2x to the 2/3. And then negative 2x to the 1/3. And then minus 4. And then notice these have the same exponents. So I can combine this. And I can combine this. X to the 1st minus x to the 2/3 minus 4. Okay, so this is x minus x to the 2/3. Wait a minute. Oh no, those cancel, right? Minus 4. All right.